Well, it's my first IMC, so I gotta say that I'm learning a lot with you all. It's a very interesting conference. We're definitely attending again. And well, my name is Caroline Menegat. I've been working in maintenance for the last 10 years now. And today I'm gonna talk a little bit about real problems and how to solve them. I know we've been hearing a lot about technology, about how it changes the world and all. And I know there are a lot of buzzwords. I've been to a lot of the sessions and AI, machine learning and all. I'm gonna have a little bit of a more practical approach and showing how we actually solve problems using technology, which is just a mean and not an end. That's what I believe. Here, guys, in terms of just starting with an analogy, before we get a little bit deeper on this, why is vibration condition monitoring so vital? I have an analogy with the human body. Just like the assets, we gotta do our checkups, or at least we should be doing, checking blood pressure, heart rate, and all these kind of things. I believe with the machines is the same. And of course, it's not just about monitoring. We gotta take action, we gotta act predictably. So it doesn't matter, or I won't do anything if the doctor tells me that I have a disease that will, I don't know, pass out in 5 days. So we gotta act proactively, and I will be discussing this a little bit more. And here at this point, I don't think anyone still has to be convinced about condition monitoring, but just some highlights why it's such a hot topic these days. Operational efficiency. So there is definitely a pressure to increase productivity, to reduce downtime. So that's definitely the top reason. Also, complex machinery. It's normal for me to visit some plants and old machines you would like for a specific operation. You would need 3-4 machines, old machines, and now it's all being replaced by one machine that does it all. Of course, it does get more complex, variable speed, variable operation. So that's another thing here to highlight. Also, sustainability. There is definitely a good pressure to actually increase life cycle of assets, to reduce waste, to have a lower energy consumption. So that all adds to the table as well. And definitely increasing competition. We're seeing this all over. It's full of competitors here. From Dynavox, for example, the company I work for. So everyone is welcome, but it's definitely increased competition in this market. And the industries that don't embrace innovation, they're definitely going to stay behind. So that's another reason that I would like to highlight a little bit here. And what I mean by condition monitoring, I attended a few other conferences here, a few other sessions, and I saw a lot of people talking about vibration. I just would like to highlight that I don't believe it's all vibration. Definitely is one of the most important metrics that can be monitored, but that's a lot more than that. And when we think here, I put like the first part is all about power generation. So all about providing energy for the rotating equipment to work. So here we divide it into this. And here we list that it's, again, not all about vibration. So that's definitely electrical analysis that can be performed, oil temperature that can be performed throughout this whole chain. So there are a lot of more variables to monitor here. And yeah, we'll be covering this a little bit more. And the reason why I put this together is to have a broader spectrum, not to just be focusing on one single thing. I'm not saying here that we should be monitoring these variables for all the assets that we have in an entire plant. That would be very expensive, and we would have so much data that we would not even know what to do with these things, okay? But that's why we should prioritize. Usually I attended the other session, they were talking about RCM, reliability-centered maintenance. So I know that there are those 7 magical questions. So what's the function of your asset? How it will fail to perform those functions? What are the causes that can happen? What if it fails? What are the impacts? So this will definitely help deciding which variables should be monitored, okay? I have an example here. We been monitoring for an agribusiness company, been monitoring line shafts. We solved the problem in terms of vibration. They even changed the lubrication plan they had based on vibration. But then, so we got rid of that, and the current and voltage or the electrical motors, they started to be the headache now, because electrically there was no monitoring. So that's why you should really get to the root causes and then decide what to monitor, what to prioritize. And here, guys, just out of curiosity, I used the Google trend here to check on how much we been talking about condition monitoring and predictive maintenance. These are definitely hot topics now. So we can see this is more or less 2010 here, I think 2018 here. So basically, never before we have spoken so much about these topics. So it's definitely trending, and you guys can see that it's going up. Here it's an index that Google uses. So it rates from 0 to 100, and you guys can see the predictive maintenance at this moment at 100. So it's definitely a hot topic, and that's one of the reasons we are here, I believe. But yeah, there is still a long path to go. We've been talking and discussing this, but here there are some other researchers that I brought to discuss, and here there are a bunch in the market, so this is just one of them. Here is the source, and basically here are the levels. So they categorize the different companies that they searched in levels of maturity. So level 3 means real-time condition monitoring. So they're doing the condition monitoring already. And PDM doing something about it or being predictive, only 11% here. So that's still a long path to go. And another study here brings the cultural maturity. So I'm not even talking about already implementing. I'm talking about being ready to implement or to have a predictive program, where only 46% they consider of the researcher here, they consider that they have the requirements to successfully implement predictive program. So that tells us a lot, the long path we still have to go. And I don't know if anyone here would categorize the companies in this level here. Anyone care to share if they have a predictive program already in place, successfully implemented? Anyone here? Nobody yet? Nobody's part of this 11%? What about the condition monitoring? Are you guys doing some condition monitoring, maybe still structuring the predictive program? Anyone care to share a little bit? I think the microphone.
Here you go.
At Hill Air Force Base, we've had a full-blown predictive program that's been widespread since, I want to say 2014.
Oh, wow.
What's held us back has been manpower.
Manpower?
They want us to do everything from oil analysis to ultrasound, and they've now added other locations, and we're down to 3 people. So
oh, wow.
We're doing our best, but it's there. It's just we can't be everywhere at once.
Yes, I attended yesterday. I think it was from NICARE. They were sharing this the lack of skilled people. So that's definitely a problem. Everyone is facing the same trouble. I will discuss a little bit how we can help on this, or basically, not saying your case, I think 3 people, down to 3 people, there's not much that can be done other than hiring. But that there is definitely, you can optimize their work. So I'll be discussing this a little bit more. Anyone else would like to share their programs or the condition monitoring, what they're doing, if it's been successful or not? No? I'll move forward then. You guys are shy today. Well, guys, let me move forward here. Oh, this one. So I do believe that technology can help on lack of people, help on getting things safer. That's definitely one of the main reasons why technology should be applied. And here, one that I would like to highlight in terms of collecting data, or one of the reasons that we should be moving to continuous condition monitoring, is hard to access or high risk measurement locations. So I do have this picture here. Yeah, here it goes. So it's a person, this is a drilling rig, that's a mining operation, and this is a highway truck. So you guys can see that this person is definitely, even though it's a controlled operation, I mean, it's not running full speed at this specific moment, it's still a risk. So the head of the person is here, like this thing rotates. So it's definitely not a safe thing to do, not a safe task. And that's one of the reasons that technology should be applied. Also here, a vast number of assets that should be monitored. So if you can automate this and bring technology to help on this, it would definitely help on the lack of skilled people. And also here, one thing here is that if this person is, I'm not gonna be in the fight of wired or wireless. To be honest, I don't think we should even be having this discussion because it's just a meme. But here, if the person is spending, 70, 80% of her time here collecting data and not analyzing it, that's definitely not bringing value to the table. So that's another reason to help. And also here, assets with intermittent or variable operation. So there are some events that happen at some point, and then when you go measure it, it's not happening anymore. So having a continuous condition monitor will definitely help on this. And again, it doesn't matter if it's wired or if it's wireless. I don't really care about it. It's just if it's vibration or if it's electrical. But these different operations, they need, sometimes they need technology to be monitored. And what else here? Another research that I brought here, guys, and again, the links are all here for you guys to check it out. But 5 golden rules to successfully implement predictive maintenance at scale. So they found out that these are the main reasons. And the first one would be to be judicious about which assets to include. We do see a lot of companies starting with pumps or fans, like very easy or not easy, but they can be very critical, but don't get me wrong, they're not complex assets. So they implement on that, and then when they try to expand, it doesn't work to more complex assets. Yesterday I was actually watching a session, and the guy next to me, he said, we started applying, it was vibration sensors in this case, we started applying, and then when we moved to another plant, we found out that it wouldn't work there because of environmental reasons, because of the robustness that was not present. So not saying it's a bad technology that they chose, I'm just saying that you should consider this when choosing and not go for the easy wins, let's say. And also, I put it here that the key, I think it's to balance a little bit. We're seeing companies starting with the most complex assets they have. I don't think that's the way either. You gotta have a manageable scope, but with assets that can actually show value when you predict failure. So that's one of the things. Another thing, provide sufficient time to improve models. So let's be very clear. I mean, everyone here is talking about it. There is no miracle AI. So you do have to give time for the models to operate, to help. Adjust or refine your models are also very, very important. And it's a learning process. Another thing, and we're seeing this in other sessions as well, put people first. So if the people are not engaged on this, forget about it, it's not gonna work. So definitely another golden rule here. Another one that they listed here in this research is build predictive maintenance into the organization's digital ecosystem. So it's very common for us to see a fight between the IT team and the maintenance team. The IT team doesn't understand that the maintenance team is a client of theirs and should be helped. And the maintenance team don't understand, for example, data security or this kind of thing. So it's always a fight, and usually they don't work together. So I don't think, and we don't think that this implementation, the predictive maintenance program should be isolated or should be one side or the other. It has to be all together. And the last one, and I don't want to be commercial here, guys, but consider the right partners. So if you choose a partner or if you choose a vendor that only sells you technology, I don't think that's the right way to go, okay? So again, not trying to be commercial, but we believe and we've seen that the most successful implementations is when a partner brings expertise, it brings guidance to what you're trying to implement. So that's another thing to consider here. And again, some assets are, even though they can be very critical, they're easy to monitor. So these assets here, I'm not saying they're not important, but be careful if you're only focused on these things, like only on these assets. Think of a little bit broader. And here lies a question about how to monitor entire plants. So if you're not just focusing on fans and pumps, which are easy, how to monitor entire plants when we are talking, for example, I got the mining example here. Guys, I didn't know, as I said, it's my first IMC, so I didn't know what to expect, who actually attends. I didn't see a lot of mining, people from mining sector, but you can think of this as any other sector, any other plant, okay? What I want to highlight here is that basically, here are the fans and the pumps. This, again, easy, but when we start gathering from the beginning, the extraction of the ore, and then we get, for example, vibrating screens, we try to process this material, or even power generation before that, that becomes a little bit more complex. And I'm sure that in the companies you guys have, we do have the same idea, maybe not mining, but you do know which assets are more complex in the environment. So here, another one, for example, this is a bucket wheel that's a reclaimer. This is very difficult to monitor as well, till here when you ship the product. So all of this, and this is what I mean by entire plants, all of this should be considered in the program, in a predictive program. Not just the easy ones, those ones everyone can do, okay? And when it comes to these more complex assets, usually they have variable speed, usually they have intermittent operation, and they require expertise. It's not just about putting sensors. Again, never mind if it's a vibration, electrical, or what, but yeah, we definitely gotta have some expertise. So the question would be, how do we monitor this? And unfortunately, I don't think there is an easy answer. I don't think there is a recipe. But in the experience, the last 10 years, we've been seeing this. There are two from the 5 golden rules, 2 rules here that stand out the most. And the first one would be this one. Be a little bit more judicious about what you choose to implement. So again, don't run away from the most complex assets. I mean, they can have the best benefits or the best results. So you should actually look for them and implement on those ones. And I saw some talks about I said again, wired and wireless sensors. I don't think that's what should be discussed. And that brings me here to consider the right partners. And again, I don't want to be commercial, but you gotta choose a vendor or a company that work together with you in your core business, producing whatever you guys are producing, and the other part helping you guys improve reliability. So that's what I'm gonna show you guys a little bit more. And here, it's some use cases that I wanted to highlight. And again, guys, I'm sorry if the examples are a little bit too inclined to one sector or other, but again, I'll take a conveyor belt. I think a lot of different sectors can have conveyor belts. So here, if we were choosing the easy, again, would be the motor and the gearbox, and maybe the pulleys, right? So maybe the pulleys here. We did, with this client, with this mining sector, in the mining sector client, we did we mapped everything that were giving them headaches. So that's how we worked together. And we listed here all the different parts that could present problems. And again, there won't be enough time for me to show here, but we are monitoring electrically the motor. We are monitoring in terms of vibration and oil. We are integrating data and monitoring the gearbox. But here I focused a little bit on more complex parts of the components of this machine. One of them would be the transfer chute. For you guys that maybe are not familiar, this is when you want to transfer the material to another conveyor belt, one to the other. You basically have a transfer chute. And it's really difficult to monitor because it's not even rotating. So how do you do that, right? So in this case, there we go. In this case, we installed sensors in the surface, like in the sides of the transfer chute, and a bunch of transfer chutes. And we were basically buying data or getting as much data as possible. And we found out as with time, these plates here, they would get worn out. So we could compare a new one or one that's working just fine or not worn out, and one that is worn out here. I think it shows better. So this is the difference. So we could monitor this and get to this result. Again, selling solution and not just sensors. So we're working together on more complex assets. Here another one, it's the coupling. So there is, the coupling here can present slippage or high stiffness. So we installed sensors on this, and we were comparing, and we got a very good model. So we improved this model, as I said, with time, because you got to give time to things. And then we got an accuracy of 95% in terms of slippage. So we can definitely monitor this now. This was a big problem for them. And another one here, belt scrapers. I don't know if you guys are familiar, but it basically cleans the belt. It basically doesn't, like, it scrapes the belt. And you guys can see the lifetime here was 25 to 30 days. These blades, they get too thin or they get damaged. And then we improved from 40 to 45 days, more or less, the lifetime. So that's another thing in another project that we work together. Again, trying to be not just selling sensors, but working on presenting a solution for this. Another one, and again, sorry for maybe being too inclined to mining, but vibrating screens. Here I won't go into a lot of details, but it could also be applied to vibrating screens that are not in the mining sector. This one, for example, is for agribusiness, so we can definitely monitor that one as well. And what we are trying to do here is, again, not the basics, like, again, monitoring the motor and the exciters. It won't be that difficult. It is for vibrating screens because the machines vibrate a lot, so you do need a very robust system. And if you put a wired one, that will definitely damage the cables very easily. So in this case, we put the sensors, again, in the motor and the exciters. But we mainly focus on monitoring, and here comes the performance. So that's when we stop just monitoring the condition, and we stop just talking to the maintenance team, and we become appealing to the operation or become appealing to managers in a high scale. So basically we put sensors here on the springs, and we monitor. Let me see if I have here. So the sensors go around here. And we made, these are some cases of success. That won't have any, but here, we can identify problems in the springs, for example, because that will change how the vibrating screen is moving. So if it's supposed to make like a circular movement and it's now performing linear, it's going up and down, you can know that there is something wrong, or if the amplitudes are different, so you can know. So we created a whole solution for evaluating, and again, not just the motors and exciters, but the structure. If the vibrating screen, for example, is vibrating like this, the left side, for example, is not absorbing vibration as it should, it will definitely have a crack on the structure. So that's one thing. And another thing is performance. It doesn't matter that you're not having a structural problem. If you're not performing, that's not good either. So that's another thing we created with this client. And we are monitoring and giving proactive actions or recommendations of what could be done. So that's another example. And mills as well. So here we are monitoring the motors in terms of electrical problems. So we did find very good results, but we we wanted another challenge, and here we can see 2 mills. This one is brand new, and this one is actually worn out already. We can even see that it's older. So what we did, we installed, they wanted to see as the body of this mill, if inside it was getting thinner, so it would lose performance. So we installed as well sensors on the surface of this machine, on the body, and then we could see here, let me just zoom in a little bit. We could see the patterns in terms of vibration, the different sensors installed along the body. And here, I think this one is more clear. Yeah. Here we could see when it was a new one and when it was an old one. So nobody does that. Like, everybody just wants stick sensors or monitor the motor and the gearbox, and that's it. Nobody goes to a deeper analysis. So that's what we are trying to say here, that you should be looking for someone who can actually work together with you, bringing expertise. So that's the main thing here. And again, monitoring performance. And there's a lot more. And these are thickeners. This is why I don't say that we should be fighting wireless versus wired. In this case, the 2 types of sensors need to be used. You cannot just monitor thickeners with wireless sensors. That's not possible. We tried. You gotta have a mix. So that's one thing to consider. These are laminators or flaking mills. These are locomotives. So we can also monitor all this working together. And to finish here, hopefully, what we achieve based on this, hopefully what we get more is changing the mindset, not seeing maintenance as just an expense, just a cost, but seeing maintenance as a strategic investment. So that's the main thing here. So providing solutions or having solutions that work together and bring results. And that's, of course, pointing out or making it show in terms of cost as well, in terms of savings. So that's what I wanted to share with you guys, a little bit what we've been doing and a little bit what we believe it's the right way to go in terms of maintenance and the predictive implementation. Thank you, guys. Here's my contact. Thank you. And again, sorry. I saved a few minutes if you guys have any questions. It seems to be a shy crowd, but there you go.
How did this whole journey begin? I mean, man, I've got one of my plants is at a mine. We were just there last month going, wow, look at all this stuff. But so how did it begin of somebody to say, hey, we got all this equipment and maybe there's a better way? How did that start?
Yeah, how it begins? Well, first you gotta, before implementing anything or before really bringing a partner or a vendor to the table, I think the company has to have clear what they want with a predictive program. Otherwise, it's just gonna be a bunch of companies trying to sell you stuff. That's the way we're seeing it. I mean, it's full, again, like in the booths here, we're gonna see a bunch of people or a bunch of companies, good companies, don't get me wrong, but trying to sell you. So if you don't know what you want, you're probably not gonna be able to find it. But what I would, again, look for, and I don't wanna be commercial, not selling Dynamox here, that's not the point, but maybe looking for companies that already have experience, have the background on what you guys are doing. So for example, I was talking about mining. If a mining company or if agribusiness or paper and pulp comes to Dynamox these days, we have lots of experience of what others have been doing and how to help. I don't know if that answers the question. It's not easy. It's definitely not easy.
I see it all the time. What's the choices that I ask myself, what's it going to do for me?
Exactly. Yeah, because we see technology as an end. We shouldn't really be doing that. We should see it as a mean to get to a solution for a problem that we have. And that also brings, I was attending the other session, they were saying, or the guy again was saying about, talking about people, like usually there's a lot of resistance on shop floor people, for example, because you bring a new toy, they don't even know how to use it and doesn't solve a problem for them. So that's one way of killing or not even starting a good project, right?
So congratulations.
Thank you, Fabio.
Great presentation. And I was really amazed to see that you guys are using vibration actually to monitor not actually rotating equipment, but equipment that, thank you. That equipment that actually moves, and then you use the vibration to diagnose it, especially like steel plates, like you showed. You are not actually measuring the thickness, but the vibration change based on the thickness, right? That's what I understood.
That's correct. That's
So
correct.
the challenge, again, when you talk about monitoring everything that moves, rotates and everything, easy peasy, right? Because you have vibration, you put there, you monitor, you have the diagnose. And like you said, we go downstairs now, 4 p.m. Over there, you have a ton of vibration
Yes.
technology. You can choose. All of them are good. The challenge is static equipment that does not move. That is the challenge. When you talk about like pressure vessels,
Yes.
pressure vessels, hydraulic hoses, water hoses, things that not necessarily moves. That part we still rely on sensitive inspection.
Oh, yes.
People
That plays a
go
big
there
part.
and see, or even time-based maintenance, meaning like a hose, a hydraulic hose, you have to change based on time, but still you have to monitor that life. So when you install a new hose, you have to know when you install it to after 6 months or a year change it. So that is the challenge. Static equipment. I don't see a lot of technology yet for this type of equipment, for this type of assets. So my question to you is this: Dynamox, is Dynamox looking into this direction or not?
I would say yes, but there are so many static equipment or so many. There's a lot of variety in this term. So there are things that can be monitored. For example, pressure vessels or something. You can basically install a camera, a thermographical camera, for example, and check the temperature if it's increasing or not. So we do have a solution for that. Some things you can go with a vibration, like installing on the sides, on the surface. It won't be as easy as a rotating equipment, but it will definitely be able. Most of the times you are able to see the different patterns of behavior on that one. So I would say that it has to be studied case by case and see what variable really stands out when there is a problem, So I would say that there is no miracle, definitely no miracle. And discussing or like bringing people who understand or have experience on this and trying to figure out a way on a specific need. That's what I would say. If anyone tells you that they are going to monitor all static things that there are in the world, that's definitely going to be a lie, but there are ways to try, I think. Perfect. Thank you, guys. Anything else? Anyone else? Oh, please.
Thanks. How long after implementing the program did it take you to begin seeing results, or did you see reduced downtime as a result? And how long would you say after you implemented it on, say, another question as part of this, did you begin with, say, implementing it on your most critical assets, or maybe we're going to approach the bad actors first?
No, that's a good question. We have a tool inside our system that allows people to register how much money they invested on the system and how are the savings going, the cost avoidance, let's say. So you can monitor, and based on the reports that you're having on the system, you can put how much money you saved, comparing if it was a catastrophic failure, if it like really failed, it was a reactive maintenance, or if you act predictively. So you do compare that, and that helps you proving the value in the system. but it does change a lot. It depends on, like, each program has a different way. And for example, mining, every hour that it's not working, the equipment is not working, it costs a lot of money. So in those cases, it can be a little bit easier. Paper and pulp is the same. So a lot of sectors, they're very costly. So you can prove, like, faster, the results that you can have. But what we see, the ones that are successful, you always choose the most critical machines to start with. Those are gonna be not quick wins, but they are gonna be good wins, I would say. So, but again, I'm no specific, I'm really against giving magical numbers, guys, so I don't have any, but you can definitely track on that and keep showing, and maybe not just being seen as maintenance, but like getting appeal from the operation side and the managers or directors in the program, especially when you can improve performance, not just when you can predict failures, because that's also important, but when you can improve the performance of an asset, like the vibrating screens keep performing better, or the mill, you can save the operation or produce more based on that. So that's another way to bring the results to the table. Anyone else, guys? Thanks for the questions. Been really, really interesting. I like when people participated. Otherwise, it's just a standalone talk here. Anyone else? No? Well, thank you very much, guys. Thank you all.
Thank you, Caroline.